A chip that defies imagination, solving in minutes what would take billions of years. A revolution brewing in medicine, energy, and AI posed to change the world. Google's quantum chip, Willow, isn't just a leap forward. It's the key to unlocking mysteries humanity never dared to dream possible. The future begins now. Quantum computing has been long considered the holy grail of technology, a field so advanced that it could revolutionize everything from healthcare to cryptography. Now, with Willow, Google has pushed the boundaries even further, claiming breakthroughs that could redefine what we know about computing. But what does this mean for us, and how close are we to seeing these changes? Google's new quantum chip, Willow, is more than just another tech innovation. It represents a seismic leap forward in how we think about computation itself. To understand its importance, let's start with the basics. What makes quantum computing different? While traditional computers rely on binary bits, essentially zeros and ones, quantum computers use qubits, thanks to a principle called superposition. These qubits can exist as 0, 1, or even both at the same time. Think of it as juggling multiple outcomes simultaneously rather than processing one at a time. The result, quantum computers can solve incredibly complex problems exponentially faster than classical systems. But here's the kicker. Achieving this kind of performance isn't just about speed, it's about unlocking problems that were previously impossible to solve. Imagine trying to predict how a new drug will interact with the human body. Classical computers can't handle that mind-boggling number of molecular interactions involved. Quantum computers, however, thrive in such high-dimensional spaces, allowing for faster, more accurate simulations. With Willow, these possibilities are closer than ever. Willow is operational in a realm of power that feels almost mythical. But here's the question for you. Can this technology truly deliver on its promises, or is it just hype? In 2019, Google announced it had achieved quantum supremacy with its Sycamore processor, solving a complex problem in 200 seconds that would have taken classical systems 10,000 years. While this was a milestone, critics were quick to point out that the problem solved wasn't particularly useful in the real world. Willow, however, isn't just about benchmarks. It's about scaling up quantum computing to solve real-world problems. One of Willow's most significant advancements lies in its ability to correct errors. Error correction has long been a thorn in the side of quantum researchers. Qubits are incredibly delicate, prone to interference from even the tiniest environmental fluctuations. This fragility causes errors to pile up, limiting the practical applications of quantum systems. Willow changes the game by incorporating advanced error correction protocols. These advancements also highlight the collaborative effort that the quantum breakthroughs require. Google's team didn't develop these protocols in isolation. They built this upon decades of theoretical work, including foundational contributions like Peter Shor's algorithm or error correction. By combining academic insights with industrial-scale resources, Google has demonstrated the importance of interdisciplinary approaches in tackling quantum challenges. It's a testament to how fast the future of quantum computing will depend on partnerships between researchers, engineers, and technologists worldwide. Google's research demonstrates that as they scale their system from 3x3 grid of qubits to 7x7, error rates didn't just stabilize, they decreased. This is a breakthrough that could make large-scale quantum systems viable. And it's not just error correction that makes Willow remarkable. The chip also boasts an extended coherence system, the period during which qubits can maintain their quantum state. With earlier quantum systems, coherence sometimes were so brief that meaningful computations were almost impossible. Willow's coherence time has been extended to nearly 100 microseconds. This improvement in coherence time is more than just a technical feat. It's a sign that quantum systems are finally moving towards practical utility. With longer coherence times, researchers can explore more complex algorithms, testing how quantum computing might solve real-world problems in fields like logistics, manufacturing, and financial modeling. For example, imagine a supply chain optimization not just for cost, but for the kind of sustainability, a scenario made possible by the kind of precision computations Willow enables. That might not sound like much, but in the quantum realm, it's a massive leap forward. What's even more impressive is that Google has taken control of the entire quantum chip production process, building Willow in its state-of-the-art facility in California. This vertical integration means the company can iterate faster and push the technology further, cementing its lead in the race for quantum supremacy. So what does this mean for the world? let's take a look at some of the most exciting applications of quantum computing. First, let's talk about healthcare. Developing a new drug is expensive, a time-consuming process. It currently takes years to simulate molecular interactions, and even then, the results aren't always accurate. Quantum computing could change this entirely. Willow's ability to process complex molecular data could lead to the discovery of life-saving treatments in record time. Imagine a world where cancer therapies are tailored to your genetic profile, or where antibiotics are designed to combat superbugs before they even emerge. This could also revolutionize how we tackle global pandemics. Quantum simulations could rapidly predict how a virus might evolve, allowing scientists to develop vaccines and treatments before outbreaks occur. The COVID-19 pandemic showed us the critical need for faster responses in healthcare, and quantum computing could provide a much-needed edge in staying ahead for emerging diseases. The speed and accuracy Willow offers could make this vision a reality. This isn't just speculation. These are real possibilities unlocked by quantum systems like Willow. And then there's energy. As the world shifts towards renewable sources, managing energy grid becomes a colossal challenge. Quantum algorithms could optimize power distribution, storage, and consumption, making energy systems more efficient and less wasteful. Let's picture a future where blackouts are a thing of the past, and renewable energy seamlessly powers our cities. With quantum computing, that future is within reach. But the benefits don't stop there. Have you heard of nuclear fusion? This is the process that powers the sun, and the scientists have been trying to harness its clean, limitless energy source for decades. The problem: fusion is incredibly complex to model and predict. Quantum simulations could crack the code, bringing us close to solving the global energy crisis. Here's another game-changing area: cryptography. Right now, your online data is protected by encryption methods that would take classical computers millions of years to crack. But quantum computers could break these codes in a matter of hours. Sounds scary, right? But don't worry, quantum computing also offers solutions. Researchers are already developing quantum-resistant encryption to stay ahead of the curve, ensuring that our digital world remains secure. Of course, quantum computing has implications for artificial intelligence. Training AI models always involves processing enormous sets of data and solving optimization problems, both of which are quantum computing's strongest suit. Imagine a smarter AI system that can diagnose diseases, predict climate patterns, or even understand human emotions better than before. The synergy between quantum computing and AI could unlock innovations we haven't even dreamt of yet. But before we get too excited, let's take a step back. Willow is a groundbreaking achievement, but it's not the end game. Practical, everyday quantum computers are still years, if not decades away. Even Google's own researchers admit that commercial applications of quantum systems won't likely appear until 2030s. The technology in this infancy, and there's a lot of work to be done before it becomes mainstream. So where does that leave us? The unveiling of Willow has sparked a global race for quantum supremacy. Nations like China, the United States, and the European Union are pouring in billions into quantum research, recognizing its potential to reshape industries and alter geopolitical power dynamics. Quantum computing isn't just a technological innovation. It's a strategic one. The question is, who will lead the charge? The competition isn't just between nations. Private companies are racing too. IBM, for example, has its Quantum System One, a system aimed at offering quantum computing services. Meanwhile, Microsoft is leveraging its Azure platform to create a hybrid classical quantum ecosystem. We ensure this technology benefits humanity as a whole, rather than depending on existing inequalities. How do we prevent it from being weaponized or used for malicious purposes? These are questions that demand our attention as we navigate the quantum age. If the journey in the quantum future has sparked your curiosity, don't forget to like, share, and subscribe. What do you think? Could Willow truly change the world, or are we still dreaming? Let us know in the comments below, and stay tuned for more explorations in the technologies that's shaping our tomorrow.
And remember to be uniquely you.